Today we are going to talk about Monte Carlo simulation. Monte Carlo refers to a city in Monaco, which is very popular for its casinos and gambling. In terms of simulation, Monte Carlo simulation is synonymous to randomness, just like randomness in gambling. But what basically is Monte Carlo simulation? Monte Carlo simulation is a model that is used to predict the probability of different outcomes when the intervention of random variables is present. Let me give you an example. Suppose you have a coin, and when you toss a coin, there are two outcomes, head or tail, and you want to determine the probability of showing up head. In order to do that, via Monte Carlo simulation is you will toss the coin as many times as possible and record every outcome in the experiment. So the probability of showing up head is actually equal to the number of times head appears in the toss over the total number of tosses. So that is actually the main idea in Monte Carlo simulation. You will just repeat the process over and over again as many times as possible. And from that, you can infer probability of an outcome based from the experiment that you have made. It actually helped to explain the impact of risk and uncertainty in prediction and forecasting models. So, Monte Carlo simulation is not just tossing a coin or just determining the probability of an outcome. It can also be used to predict based from the model that you have and to forecast some phenomena or some scenario that may happen sometime in the future. And the basis of Monte Carlo simulation involves assigning multiple values to an uncertain variable to achieve multiple results and average the results to obtain an estimate. So again, when we say Monte Carlo simulation is you will just do the process or do the experiment over and over again with embedded embedded in that experiment is the random variable being considered. So it is very important also to know the corresponding probability distribution or probability density function associated to the random variable you considered from the simulation or from the experiment. Let me give you several examples on how we could use Monte Carlo simulation, and I will also show some R codes to determine or to just to illustrate these examples. Let's say, for example, we want to estimate pi or estimate the value of pi. Okay? And how are we going to do this? Okay? So, ito yung magiging experiment natin. Let's say we draw a square. Okay? Uh, we draw a square where the vertical lines is defined by x equals -1 and x equals 1, and the two horizontal lines are defined by y equals 1 and y equals -1. Okay? And from that square, we will inscribe a circle. Okay? And then ang gagawin natin is imagine that we will throw darts to that figure. Okay? And in throwing darts, we will count the number of points or the number of darts that is in the circle. Okay? And we also determine the total number of darts that were inside the square. Okay, so that's basically the idea. In estimating the value of pi is just throwing darts. Okay? And how do we estimate the value of pi using Monte Carlo simulation? We know, based from this, that the area of the square is 4 because the side of the square is 2. Okay? And the area of the circle is pi. Okay? And since the area of the square is 4 and the area of the circle is pi, so this is how we will estimate now the value of pi. The value of pi is approximately equal to 4 times the number of points in the circle divided by the number of points in the square. When we say the number of points in the square, this means the total number of darts thrown, okay, including those points that were inside the circle. Okay? So, ito yung gagamitin nating method in order to determine the value of pi. Of course, mas okay ang precision or okay ang accuracy ng pi if the number of darts to be thrown from this diagram is as large as possible. Okay? And let me show you an arco to this one. Okay? Again, that is the idea. Okay? So first, i-define natin yung total number of darts to be thrown. Let's say, mag-start tayo with 100. And then after that, i-define naman natin ngayon yung uh, number of darts na pumasok sa loob ng circle. And in this case, we initialize it to 0. And then from that, uh, we will now define x. Okay, so take note, since nagto-throw tayo ng dart on a two-dimensional system, so bawat point, merong corresponding ordered pair for that one. So yung x coordinate, we will define it as run if n equals 1, minimum equals -1, and maximum equals 1. So ibig sabihin, pumipili tayo pumipili tayo ng x coordinate between -1 to 1. And when we say run if, we are assuming that x is uniformly distributed over the interval -1 to 1. Okay? On the other hand, kailangan din natin ng y coordinate. So similar to x, kukuha rin tayo ng isang number from -1 to 1. So the minimum value is -1 and the maximum value is 1. Okay? Ibig sabihin, pag meron tayong x and y coordinate, such that the minimum value is -1, the maximum value is 1, sigurado tayo na yung point na mapipili natin is inside the square. Right? And, of course, gagawin natin yung pag-throw ng dart for a total of 100. Okay? But in this case, of course, kailangan natin ng loop. So, kailangan natin ng loop. So, it should be 4 I in 1 to the total number of points. Okay? At dito sa loob ng loop na ito, bibilangin natin ngayon kung ilan sa mga points na to yung pumasok sa loob ng circuit. And how are we going to do that? Okay? Nasa loob ka ng circle kapag yung distance ng point mo from the origin is less than 1. Otherwise, kapag yung distance ng point mo from the origin is greater than 1, then you are sure that the point is outside the circle. So, kailangan natin ng ah, decision condition dito. That is, if yung x squared plus y squared ay less than or equal to 1, okay? Pag yung x squared plus y squared ay less than or equal to 1, ibig sabihin yung point na napili natin is inside the circle. So yung number of points inside the circle ay madadagdagan ng isa. That means the points inside the circle is actually equal to the points inside the circle plus 1. Right? And after that is we will print the result. Ano nga ulit yung result natin? Ang result natin is 4 times the number of points inside the circle divided by the number of points inside the square or the total number of points. So if we print natin 4 times yung points inside the circle divided by the total number of points. Okay? So let's see the result. So kung meron tayong 100 points to be thrown inside the square, so 3.28 is the approximate value for pi. But since ang kinonsider natin ay 100 points lang, medyo malayo yung 3.28 from our expected value. So one way to increase the accuracy of our estimate is to increase the number of points. Nag-start tayo with 100. Let's say gawin natin 1 million. If you make it 1 million, yeah, tatagal ang computation kasi uulitin niya yung loop for 1 million times, and based from this, the approximate value of pi is 3.1381. Okay? Run pa natin ng isang beses. The approximate value of pi is 3.141116. Okay? But take note from that computation, kung mapapansin nyo, medyo tumagal yung calculation kasi isang milyong beses niyang inuulit yung nandun sa loob ng loop natin. Okay? So, simplify natin yung problem para mas dumali yung computation. So, ganun pa rin ang gagawin natin. 1 million number of times nating 1 million number of times tayo magto-throw ng dart. So, again, define natin yung total number of points to be 1 million. Pero dito, define natin ngayon yung x as a vector containing 1 million points. And mamimili lang tayo ng mga numbers from -1 to 1. Similar with y, ganun ulit ang gagawin natin. So in this case, matrix operations yung gagamitin natin. Okay? So take note, x and y are vectors here. And ngayon, i-define natin yung distance as x squared plus y squared. Ibig sabihin, nagkikreate tayo ng vector kung saan ang mga entries niya ay yung distance from the origin. So, ang size ng vector na to is also 1 million. Then, after that, Nagke-create tayo ng another vector, pero dito sa vector na 'to, ang ilalagay lang natin sa loob ng vector na 'to ay yung mga values nung vector na distance kung saan ang value niya ay less than or equal to 1. Ibig sabihin, inilalagay lang natin sa vector na 'to yung mga points na pumasok dun sa loob ng circle. Okay? So finally, yung similar variable as before, yung number of points inside the circle will actually be the dimension of the vector in circle. So, we can print the result similar as before, run natin yung code, and check na mas mabilis yung computations nito unlike before. Notice, 1 million times 1 million times pa rin tayo nag-throw ng dart and uh, evidently mas mabilis yung computation because here we work with matrix, and based from this, using Monte Carlo simulation, the approximate value of pi is 3.14138. Run natin ulit. The approximate value of pi is 3.14146. Now, let's have a visualization of this. Anong nangyayari? Tingnan natin yung visualization nito, kung saan napupunta yung mga points na to. Um, ipakita lang natin for the first uh, 10 points. Okay? So, ipoplot natin x from 1 to I, y from 1 to I. Pero dun sa plot natin, i-fix na natin yung diagram natin such that the minimum and maximum value for x ranges from -1 to 1 respectively. And yung mga values ng y naman natin nagre-range also from -1 to 1 para hindi gumagalaw yung graph. No, so ipapakita natin yung galaw ng mga points. Okay. Yi. Then, papalitan lang natin ng color red yung pinaka-latest na point na lalabas dun sa pagrara natin ng code. Okay, kailangan natin maglagay ng freeze time para nakikita niya yung animation. So, look at this. Okay? So, yan yung diagram ng mga points pag nagto-throw tayo ng dart in the square. Okay? I hope that is interesting to you. Now, let's have another example. How do we now use Monte Carlo simulation for finding the definite integral? Okay? But in order to do that, kailangan nating kuhanin yung concept na to from the concept of expectation or finding the expected value of a random variable. So let x be a random variable, and in this case, we will assume that the random variable is a continuous random variable para lang define yung integral natin. And we define another function, h, which is a continuous real-valued function. In general, the expected value of h of x is equal to the integral over omega, h of x, f of x, dx. Take note, yung f of x dito is the probability density function corresponding to the random variable x. Kasi nga, sa Monte Carlo simulation, as I've said before, importante na alam natin kung ano yung random variable na kinoconsider natin. Similar to example number one. Sa example number one, yung random variable na kinonsider natin ay nagpa-follow ng uniform distribution. So yung x natin from there is uniform on negative 1 to 1. Yung y natin is uniform on negative 1 to 1. So pag pinagsama mo si x and y, we actually have a bivariate uniform distribution. Now let's go back again to this example. We want to find the value or expected value of h of x. So ito yung main concept na gagamitin natin in evaluating the definite integral using Monte Carlo simulation. Now, using Monte Carlo simulation, again, similar to example number one, uulit-ulitin lang natin yung process, yung experiment natin over and over again. Okay? So, using Monte Carlo simulation, yung value ng definite integral natin, which here we denote as h hat sub m, is equal to 1 over m times the summation of h of xj, j from 1 to m. Take note, yung m dito or yung capital M dito, this is actually the total number of points considered. Alright? And yung xj natin is assumed to be independent and identically distributed with respect to the probability density function f sub x of x. Okay? So the idea behind here is actually the strong law of large numbers, meaning to say, pag in-increase mo yung number of experiments, the average of that will actually tend to a normal distribution. And also this is backed up with the central limit theorem. Okay? But if you want to know more about the details of it, meron naman mga available books on Monte Carlo simulation. Pero dito sa discussion natin, ipapakita lang natin on how we can use Monte Carlo simulation in evaluating definite integral. All right? Let's have an example. Suppose we want to determine this definite integral from 0 to 1 of 1 over 1 plus x squared dx using Monte Carlo simulation. In Monte Carlo simulation, kailangan alam natin yung h of x natin tsaka yung probability density function. So, importante na alam mo kung ano yung corresponding probability density function of the random variable you considered. Alright? But before we use Monte Carlo simulation, alam naman natin yung value ng integral na to. This is actually elementary calculus. And we know that the exact value of this is pi over 4, or approximately equal to 0.78540. Okay? Ngayon, how are we going to use Monte Carlo simulation to approximate the value of this integral? Using Monte Carlo, i-define natin yung h natin. So here, pwede natin i-define yung h natin as yung buong integrand natin, 1 over 1 plus x squared. So if this is the case, kung ito yung h natin, so yung corresponding density function natin na yung f, since wala nang natira from the integral, so mangyayari na lang na yung f of x natin ay equals to 1. So kung ang f of x natin ay equal to 1, or ang probability density function natin ay constant lamang na equal to 1, this will imply that the random variable being considered is uniform over the interval 0 to 1. So importante na alam mo yung bounds of the integral. Okay? para mas madali mong makuha yung corresponding probability density function. And we know that if the PDF is just equal to 1, then our corresponding random variable is uniformly distributed over the interval 0 to 1. Okay? So, ang gagawin natin is magge-generate tayo ng several uniform magge-generate tayo ng several values of x na nanggaling sa uniform distribution. Okay? After mo makakuha ng several values of x na galing sa uniform distribution, ipo-plug in mo yon sa h of x. Then after mo makuha yung several values of h of x, determine the average of h of x. Again, mas effective ang Monte Carlo simulation kapag maraming beses mong gagawin yung experiment. Balik tayo sa R. So again, pili tayo ng points, let's say 1,000. Okay? Tapos, pipili tayo ng x. Based from this, sabi natin, ang x natin ay nanggaling sa uniform distribution where the total number of points is PTS. Uniform siya over 0, 1. So the minimum value of x is 0 and the maximum value of x is 1. From here, kailangan natin i-define yung h natin. So again, x is a vector containing 1,000 points coming from a uniform distribution on the interval 0, 1. So yung h naman natin is another vector, pero itong vector na to ay galing na sa transformation na 1 over 1 plus x squared. Okay? Then after that, once na nakuha mo na yung value ng h, ipiprint na lang natin yung average ng mga h. So, run natin yung code. Again, balikan lang natin yung nasa slide. The value is 0.78540. So, dapat medyo nasa ganyang value yung makuha nating result. If you have 1,000 points, the average value is 0.7868399. Run it again, 0.7894546. Increase natin yung number of points. Gawin na ulit natin 1 million. Okay? Kasi nga, mas maraming experiment, mas maganda ang magiging result ng Monte Carlo. 0.7853523, 0.7853333. Okay? But of course, sa definite integral, pwedeng hindi real number yung mga bounds, pwedeng mga infinite. Okay? Let us consider this another example. Suppose we are interested to find the value of this one. Integral from negative infinity to positive infinity, x e to the negative x squared over 2 dx. Okay? From here, pwede pa rin mag-work yung f of x equals 1 natin. Kung ang f of x mo ay equal to 1, take note of this, yung magiging h of x natin ay yung buong integrand natin, x e to the negative x squared over 2. But the main problem with choosing f of x equals 1, yung lower bound and upper bound ng uniform distribution mo. Negative infinity to infinity. So, posible yung mga extreme values. But the problem of that is hindi naman kasi mga real numbers ito mga infinite na to. So, mahirap maka-generate ng values kapag nasa uniform distribution ka tapos any real number yung mga possible values. Okay? So, yun yung isang drawback kung gagamitin natin ang uniform distribution. So what we can do is itong expression na to, e to the negative x squared over 2, this is actually a familiar distribution. Okay? If we consider the probability density function of standard Gaussian or standard normal distribution, okay, the density is given by this one. 1 over square root of 2 pi e raised to negative x squared over 2. Okay? So, ibig sabihin, kung ito yung gagamitin natin na h of x, sorry, kung ito yung gagamitin natin na f of x, so kailangan natin mag-multiply ng 1 over square root of 2 pi sa loob ng integral. Since we know yung 1 over square root of 2 pi ay constant naman, mag-multiply ka na lang din ng square root of 2 pi sa labas. So, hindi nababago yung value ng definite integral. Okay? So, yun yung gagamitin natin na idea. Then, yung definite integral natin ngayon can be converted to this one. Okay? Take note, this integral is also equal to the original problem. Okay, so from here, ang h of x natin is x. Ang f of x natin yung nasa loob ng parenthesis, which is indeed the PDF of standard Gaussian. Alright? So kung ang PDF natin ay standard Gaussian or standard normal, then we know that it is normally distributed with mean 0 and variance 1. Since normally distributed siya with mean 0 and variance 1, alam naman natin na kapag normal yung distribution, any real number ina-accept na value ng random variable. So yung x natin will range from negative infinity to positive infinity. And how are we going to do that with r? Okay? Gawin natin kay r. So, similar dun sa ginawa natin, let's say we have 1,000 points. Pero dito, ang pipiliin naman natin na x ay nanggaling sa normal distribution. So, hindi na mag-work yung runif natin kanina na code. Kasi yung runif na code is nag-generate ka ng values from a uniform distribution. So kapag mag-generate ka ng values for a normal distribution, ang gagamitin naman natin ay R-norm, where N is the number of points. Since R-norm yung ginamit natin, kailangan niya ng mean, which is 0, at yung standard deviation, which is 1. And after that, kailangan mo ng H. Ang H mo, based from the slide, or based from our discussion a while ago, ang H natin ay equals to X. And from here, we print yung mean of H. Okay? Run natin yung code. The mean is 0.0376386. Increase natin yung number of points. Gawin natin similar dun sa ginagawa natin kanina. Gawin natin 1 million. The mean is 0.001463637. Gawin kaya natin 10 million. Okay? Medyo matagal na. So the value is negative 3 times 10 to the negative 5. Okay? And actually, oops, wait lang. May kulang pala tayo. Kailangan nating mag-multiply ng pi. Square root of 2 pi. Sorry. Kailangan natin mag-multiply ng square root of 2 pi. Basically, ganun pa rin naman ang mangyayari. Close to 0 pa rin yung makukuha natin na sagot. Because, this expression, kung wala yung 2 pi sa labas, this is the basic expression for the mean of a standard normal random variable. And we know that the mean of standard normal distribution is 0. Multiply mo with square root of 2 pi, that will also be 0. So, dapat ang makukuha mo mga values ay close to 0. Okay? Pag in-increase mo yung number of trials or number of points, the value should be very, very, very close to 0 because indeed, the value of the definite integral is 0. So I have presented to you two examples, okay? And there are also there are still lots of applications of Monte Carlo simulations. Itong dalawang examples na to, simpleng examples lang to, but as long as you have a random variable or you have a model that involves a random variable that involves probability distribution, you can use Monte Carlo simulation. Okay? And that ends my discussion. I hope you learned a lot from this discussion. Thank you.